Our AP review topic for today is graphical analysis. Our first question comes from the 2003 AP exam, problem number 4. This was without a calculator, and the vast majority of the graphical analysis problems will be done without a calculator. So they are giving you the graph of f prime, and it says let f be a function defined on the closed interval from -3 less than or equal to x less than or equal to 4, with f of 0 equaling 3. So that's giving us a point on the original function. The graph of f prime, the derivative of f, consists of one line segment and a semicircle as shown above. They're always very clear about what you're looking at on the graphs. Part A says on what intervals, if any, is f increasing? Justify your answer. So f is going to be increasing when the derivative is positive. That was the note card for increasing. So we're going to look at this graph and say, where is this graph, which is, the derivative, where is this graph positive? It's only positive on one interval, which would be from -3 to -2. And so it says justify your answer. Your justification is that f prime of x is positive. That's all you need to say. Do not say it is positive, though. You have to use specifically what are you talking about. F prime. F prime is positive. B. Find the x-coordinate of each point of inflection of the graph of f on the open interval from -3 to 4. Justify your answer. All right, points of inflection occur when the second derivative changes signs. You can tell information about the second derivative by looking at the slope of the graph of the first derivative. This is a first derivative graph, so its slope is the second derivative. So I'm looking for where does the slope of this graph change signs. Well, that happens when x equals 0 and also when x equals 2, because I have negative slope until x equals 0, then I have positive slope. It's positive until I get to x equals 2, then I have negative slope. So the justification is going to be that the slope of f prime of x changes signs. That's all I need to say. What did I look at on this graph to tell me those were points of inflection? Or x-coordinates of points of inflection, I should say. Okay, part C. Find an equation for the line tangent to the graph of f at the point 0, 3. So for part C, if I'm writing a tangent line equation, I'm going to go to my point slope formula. Y minus y1 equals m times x minus x1. So the point is given in the problem to be 0, 3. So 0 is my x1 and 3 is my y1. So y minus 3 equals m times x minus 0. So the only thing I'm missing to write this equation is the slope. What is the slope of the original equation when x is 0? Well, it just so happens that I have an f prime graph here, which is the same thing as a slope graph. So when x is 0, I just look at the y-coordinate of this graph. It is at -2. So that means m is -2. You can leave the equation in point-slope form. You could simplify it if you wanted to. You could get it into slope-intercept form if you wanted to. Any algebraically equivalent equation would be accepted, but leaving it like this is fine. All right, part D is the last part. Often on AP questions, the last part is the hardest part. That's not always true. There are definitely lots of exceptions to that. But I would say more often than not, it is the harder part. So that's the case on this problem. Part D says, find f of -3 and f of 4. Show the work that leads to your answers. So for part D, I'm going to do that work up here. They want you to find f of -3. So I want to know, what is the actual point on the graph when x is -3? What's the y-coordinate there? So the way I'm going to find that is I'm going to start with my starting value. I know f of 0 happens to be 3. That was given in the problem right here. So I would add to that the integral from 0 to negative 3 of f prime of x dx. Why am I doing that? Well, I have to start whatever I have started with, whatever point they are given. If they had given me the point f of 6, which is not even shown on this graph, I would start with my lower limit of integration is 6 and my upper limit, the one that I am trying to go to. I'm integrating f prime because that undoes the derivative and takes me back to the original function. So f of negative 3 would equal 3 of, hang on, 3, I've got my limits in the wrong order here, so I'm going to put minus the integral from negative 3 to 0 of f prime of x dx. So I've changed the sign in front of the integral and reversed my limits. So now I just want to do the integration. When I do that with a graph, I'm looking for the area between the graph and the x-axis. So f of negative 3 is going to equal 3 minus, and now I'm going to calculate some areas. So from negative 3 to 0, I have two triangles. I have a little tiny one and I have a big one. The little tiny one has positive area because it's above the x-axis, and the big one has negative area because it's below the x-axis. So the little tiny one is going to be base times height divided by 2. The base is 1, the height is 1, and then I divide that by 2. And I'm going to add that to the negative of the area of the one underneath the x-axis. The base is 2, the height is 2, and then I divide that by 2. So this is going to be 3 minus the quantity, 1/2, minus 4 divided by 2 is 2. 1/2 minus 2, you subtract, take sign larger. So that's going to be negative 3/2, and I'm subtracting that from 3. So 3 plus 3/2 is going to be 6/2 plus 3/2 is 9/2. That is going to be the answer for f of negative 3, but we're not done because we also have to do f of 4. Okay, so f of 4 we would do the same way. You are welcome to pause the video, try this one on your own, and then check it. So f of 4 will equal f of 0 plus the integral from 0 to 4 of f prime of x dx. So f of 4 will equal 3 plus, we're looking at the area from 0 to 4. All that area is under the x-axis. So I'm going to put a negative in front of that and then find these areas. If you look at this region, it's like a rectangle with a semicircle cut out of it. So the area of the rectangle would be 8, base of 4, height of 2. So 8, and then if you subtract the semicircle, it's 1/2 of pi r squared. Pi times the radius here would be 2 squared. So this is going to be 3 minus 8 minus 4 divided by 2 is 2 pi. Distribute the negative, 3 minus 8 plus 2 pi. That's going to be negative 5 plus 2 pi. Okay, let's talk about how they would score this problem. Alright, so for this problem, part A is worth 2 points total, 1 point for the interval, and 1 point for that reason. F prime of x is greater than 0. Part B is worth 2 points. You get 1 point for having x equals 0 and x equals 2 only. Any additional answers will cause you to lose that point. 1 point for your justification, which was saying that the slope of f prime changes signs. C is worth 1 point only and that's for giving the correct equation. There's no partial credit, no work points on that. Part D is worth 4 points, and this is the way they divvy them up. They give you 1 point for figuring out the difference in the areas of the triangles, which we got was -3/2, and they will actually take that positive or -3/2 for the areas, the difference in the areas of the triangles. Then you get 1 point for giving 9/2, and you have to be using the fundamental theorem of calculus, which is where you take your starting value, which we had 3, and then add it to your integral from 0 to -3 of f prime of x dx. So anytime you're doing an integral, you have to show the integral that you used, or you will lose work points for that. So you couldn't have just written down the 3 minus -3/2. You actually have to show the integral to get that work point. So always show your integral whenever you take one. And then you get 1 point for giving let's see, what was it? 8 minus 2 pi, and they will take that plus or minus. That's the area of the rectangle minus the area of the semicircle. And then you get 1 point for giving the f of 4 was -5 plus 2 pi using the FTC, Fundamental Theorem of Calculus, meaning you had to have 3 plus the integral from 0 to 4 of f prime of x dx. That's a Fundamental Theorem of Calculus. We had a note card that was for new y value. That's actually what they're referencing there. Okay. Now we're going to go on to 2003 test B, number 5, no calculator. Every year there's 2 tests, an A test and a B test. This came off the B test. You will have a mixture of A tests and B tests when you take the AP exam in the room, more than likely. Okay, so this problem says let f be a function defined on a closed interval from 0 to 7. The graph of f, consisting of 4 line segments, that should be segments, not segments, is shown above. Let g be the function given by the integral from 2 to x of f of t dt. A, find g of 3, g prime of 3, and g double prime of 3. Okay, so this is just crank it out kind of problems. G of 3 is equal to, this is your g function. The integral from 2 to x is 3 for this problem, so 2 to 3 of f of t dt. So here's your graph of f of t, or f of x. We're doing the integral from 2 to 3, so that's this little trapezoid right here. You do have to know how to find the area of a trapezoid on the AP Calculus exam. Base 1 is 4, base 2 is 2, so 4 plus 2 is 6. Times a height of 1, then divided by 2 is 3. Oh no, that's not part B, still part A. G prime of 3. If I'm taking the derivative of the integral from 2 to x of f of t dt, this is using the second fundamental theorem of calculus. The x goes down in place of the t, the derivative and the integral undo each other. So g prime of 3 is the same thing as f of x. So for this problem it's f of 3. F of 3 is just reading the y value off of this graph. At 3 the y coordinate is 2. So this equals 2. And last, g double prime of 3. Well, if g prime of 3 is f of x, then g double prime of 3 is going to be the derivative of f of x, which would be f prime of x. And so f prime of 3 is talking about what is the slope of this graph when x equals 3. So that's rise over run. Down 2 to the right 1 is what we're doing here. You could use your slope formula if you wanted to. but that slope is -2. So there's your 3 answers for part A. Part B, find the average rate of change of g on the interval from 0 to 3. Average rate of change means the same thing as slope. You just use your slope formula. So for g, this is going to be part B. G of 3 minus g of 0 divided by 3 minus 0. We just figured out what g of 3 was in the last part. That was the first thing we found, so 3. Now we need to figure out what g of 0 is, and then we'll divide that by 3. So g of 0, we're going to find the same way we found g of 3. The integral from 2 to 0 of f of t dt. So that's going to be the opposite of the integral from 0 to 2 of f of t dt. So going from 0 to 2, we have a big triangle, base of 2, height of 4. 2 times 4 is 8, divided by 2 is 4, and then we have the negative in front, so that's -4. So 3 minus -4 would be, on the numerator, 7. 3 plus 4 is 7/3. It's the answer to part B. C. For how many values of c, where c is between 0 and 3, is g prime of c equal to the average rate found in part B? Explain your reasoning. Okay, that sounds like a mouthful, but it's actually not that hard. How many times between 0 and 3 is g prime of c? Now we just talked about what g prime of c or g prime of x was up in part A. Remember we figured out that g prime was the same thing as f of x? So this could say, just the same as g prime of c could say f of x. When is f of x, how many times is f of x equal to the average rate found in part B? Well, the average rate found in part B is 7/3. Or if you wanted that as a mixed number, that's the same thing as 2 and 1/3. So how many times is the graph shown going to hit 2 1/3 between 0 and 3? Well, at 3 it's at 2, and it goes up above that, before that, so it's going to be 2 times. So the answer is 2, and the reason, because it says explain your reasoning, is that f of x equals 7/3 2 places between 0 and 3. If you were to like draw a horizontal line at 2 1/3 on this graph, it would touch that graph twice between 0 and 3. Okay, D. Find the x-coordinate of each point of inflection of the graph of g on the interval from 0 to 7. Justify your answer. This is not a very hard last part of a problem. Points of inflection occur when the second derivative changes signs. We figured out that the second derivative of g was the same thing as f prime of x. So that's talking about the slope of this graph. So how many times does the slope change signs on this graph between 0 and 7? So f prime of x changes signs at where? X equals 2 and x equals 5. We have positive slope till x equals 2, then we have negative slope, negative slope. It changes slopes at 4, but it doesn't change signs. And then at 5, it changes from negatively sloped to positively sloped. So f prime is the same thing as g double prime of x. And that second derivative changes signs at x equals 2 and at x equals 5. That's all you need for your justification. All right, let's talk about the scoring for this. The scoring for A is 3 points. You get 1 point for figuring out g of 3, 1 point for figuring out g prime of 3, and 1 point for g double prime of 3. No work points. B, you're going to get 2 points for part B. 1 point is for having the answer, which was 7/3. And then 1 point is going to be for either, they'll give you two options, saying that you took g of 3 and you subtracted g of 0, or another option is to talk about, actually no, let's just go with that. 1 point for subtract that numerator on your average rate of change. All right, C is worth 2 points. You get 1 point for saying that it intersects 2 times. And then 1 point for your reason. And the reason that they were looking for was that either g prime of x or f of x equals 7/3 2 places between 0 and 3. Part D is worth 2 points. You get 1 point for having x equals 2 and x equals 5 only. And then you get 1 point for your justification. And your justification needed to be because the slope of g prime, which was the same thing as f, slope of g prime equaling f changes signs 2 times. Well, and where they change signs at x equals 2 and x equals 5. Saying that it was the slope of g prime or f would probably be a better answer than what I did on the last screen, which was saying that f prime or g double prime change signs, because it's best to base your justification off of the given information in the problem. They gave us the graph of f. So talking about the slope of f changing signs is probably better than saying f prime changes signs. And you definitely want to be as specific as possible about what you're talking about. Don't say it changed signs for sure. All right, you've got some more problems to work on to practice these skills. Have fun and good luck and have a great day. Bye.